All right. Well, thank you for that. Again, welcome to statistics. I've started the recording now. Um, so what I want to do here is I want to walk you through Blackboard and start by going into the syllabus before we go into our first lecture. All right. So you access the classroom as you have. You log into your Blackboard and you scroll down and you click on our link. And this is, of course, what you should see when you log in. So let me switch to student. All right, first thing you'll always come in on is this tab called announcements. Every week you'll get an announcement from me. It'll just basically be, what main topics we're covering that week. Just a reminder about our time that we're going to meet, things like that. Then you see all these other tabs over here. So I'm going to go through all of these in detail in a second. But first one you're going to want to click on is this outline and overview tab. And this right here is our course syllabus. Okay, so you want to download that. So I'm going to open it and work through it with you guys. Just out of curiosity, how many people have downloaded and looked at the course syllabus already? Okay, great. Everyone's on top of this stuff. It's great. Okay. All right, so back here, the course syllabus. So let me just start at the top here. My name is Matthew Sokol. I'll be your instructor for the course. Just a little background about me. I've been a full-time instructor now. I think this is my 11th or 12th year. It's hard to remember. They go so quickly. Prior to being a teacher, I worked in government, public, and private industry. So I have a little bit of background on the uses of mathematics in the real world. Next is my email. If you ever want to get in contact with me, my email is matthew.sokol@sunywcc.edu. I check my email multiple times a day, Monday through Friday. Being that we work at home now, I check my email probably 5 times on the weekends as well. So if you ever need to get in contact with me, shoot me an email there, and I'll respond to you as quickly as I can. I have a newborn at home, as I said previously, so if you get an email from me at 3 in the morning, it's because I was up dealing with that. Our class website is there. That's just the login to the Blackboard. So my office hours. So I hold office hours via Zoom. And my office hours are times when you can come and talk to me. If you have any questions or concerns about the class, or there's a concept you didn't understand. Going back into the classroom, there's this tab here called Office Hours, and then in parentheses, Zoom. You click on that. There's the link for my Tuesday office hours, and the link for my Thursday office hours. I'm not going to leave the Zoom open the entire time. The only thing that I ask that you do is if you do want to meet me during my office hours, just shoot me a quick email and say, hey, Matt, I'd like to meet during your office hours roughly at this time, and then I'll make it live. So just give me a heads up. So I will also, during my posted office hours here, have my work email open. So if you email me, you'll get an email back within 5 minutes at most. So my official office hours are Tuesday, 11 a.m. to 12:50, and then Thursday, 10 a.m. to 12:50. But if those hours don't work for you, let me know, and I will. We can set a different time to meet. No big deal. Okay, course materials. So we've got some good news. Your textbook is called Introductory Statistics. It's an OpenStax course. It's an OpenStax textbook, so it's a free online open source textbook. So if you go back into the classroom, I have this tab here called textbook information. When you click on that, there's a link right to our textbook here. And it's a web-based textbook, but if you prefer a hard copy textbook, you can purchase it. There's a link right here. On Amazon, I think it's $26.80, so it's real cheap. Basically, it's just the cost to print the paper. I prefer the online textbook. It's actually pretty good, and some of the sections have like multimedia built into them, so it's better to consume it on the web. So each week we'll follow certain sections in the textbook, and I'll let you know those sections that we're going to cover. So after class, to fill in the gaps of what I talk about, you should definitely skim over the sections that we cover in class. All right, the one thing you will need in this course is a TI-83 or higher, so you can use a TI-84 calculator. How many people have a TI-83 already? Okay, if you do not have a TI-83 calculator, okay, yours is ordered, perfect, great. You won't actually need it necessarily right this first week, so it's not that big a deal. But the way this course works is a lot of times in class, what I'm going to do is I'm going to show you how to do statistical procedures by hand, like the long way. And then this might frustrate many of you, but then I'll be like, okay, but then there's an easier way to do it. And I'll show you how to do it on your graphing calculator. Having that handy and with you in class, and following along when I do the calculator will be really great. So what I have here in class, what I'll do is I'll load up a emulator of our graphing calculator in class. I have a TI-83 and a TI-84 emulator, so it doesn't matter what calculator you have. Looks like my emulator's not working right now. Sorry. Clicked the wrong link, but I have an emulator here, sorry. And what I'll do is I'll show you as we're going through lecture, what buttons to press, the stat button, what all this stuff does. So having it and following along in class is great. All right, the other technology requirement you'll need is you'll need Zoom access. Obviously, everybody has it. And unfortunately, you'll need a web camera. So I'm not a stickler about turning on your web camera now. It's not a big deal at all. The only time you'll have to turn on your web camera is when we take exams. And I'll talk about that when we get to that section. But before I continue, does anybody have any questions about like the course materials, the calculator, anything like that? No questions? You'll notice that I'll ask, if anybody has any questions so I can pause and grab a sip of coffee. Okay. So course description. Let me just talk real briefly about what this, just the course description, and then I'm going to go in a little bit more detail about the course in a second. So this is the catalog description of this course. This is a general introduction to statistical methods for students in all academic disciplines. This is what I love about statistics more than any other math course you could take. No matter what field of study you're going into, psychology, education, engineering, sociology, political science, you will use statistics. It is just such a useful skill. And because of that reason, I love teaching this course more than taking teaching an algebra or pre-calculus course, because those courses, it's hard to see exactly how this translates into the real world. Pretty much every lecture we have in this class, you'll see the real world uses of statistics. And it's just my favorite to teach. Some of the topics we'll cover on descriptive methods in the presentation of data. So that's stuff like mean, median, mode, bar charts, stuff like that. A thorough treatment of the basic concepts of probability. I love teaching that section. We'll play some casino games and talk about the probability in that, so it's kind of fun. Techniques of statistical inference and decision-making through hypothesis testing, methods of correlation and regression, and application of non-parametric methods in various subject areas. I know there's a lot of words there, and maybe you don't know what does non-parametric methods mean. But over the coming weeks, we'll build your knowledge so that by the end of the semester, all this stuff you will have mastered. All right, the one big thing I hope people realize when they sign up for this course is this is a mixed mode course, or it's called a hybrid course. How many people realize that this course is half remote and half in person when they signed up for this? Or half online, half remote? Okay. So what this course is if you were to take this course in person, you would you'd be meeting twice a week for 2 hours. We only meet once a week for 2 hours. Like for example, I teach a normal, quote unquote, normal section of statistics today, and we meet on Tuesday, and then we'll meet on Thursday. So we don't do that. So as such, half your learning will be online. So if you go back to the classroom, every week I'll open up a tab for you, and let me just exit the preview for a second. You can see I have a tab for every week of the course. Forgive those dates that you see there. That's from last semester. So I just haven't changed the dates yet, but there's a tab for every week of the course. And every tab is the same. Okay, when you click on the tab, there'll be 2 folders every week. One called Course Meeting Materials. So if you click on that, there'll always be a PowerPoint lecture there that I'm going to use in class. I highly encourage you to download the PowerPoint. If you can, print it out. You'll notice, especially in the coming weeks, I'll write notes on the PowerPoint. So for example, if you look at the PowerPoint here, second. You can see what I'm typing here. It's really terrible, but can everybody see that I wrote hello there? Okay, so what I'll do every week, you'll notice as I lecture, I'll be writing notes on top of the PowerPoints. So it's useful to download the PowerPoints ahead of time and have them handy. Then when you go back to the week 1 folder, there'll always be a folder called post-class requirements. So when you click on that, there'll be, a checklist for you to follow. A link to the website, like what sections we're covering this week. And then there'll be all these folders for the different topics we're going to cover that week. So under, on your own, quote unquote, on your own, you'll have to cover the topics of frequencies, measures of central tendency and dispersion. And then a lot of times what I'll do is I'll have an extra lecture on how to use like Microsoft Excel if you're interested. That's completely optional. But when you click on the folder, what you'll have to do is there'll be I'll click play here. There'll be like a little video like I'm doing right now. You can hear me. And then you can just follow through, and there's a PowerPoint associated for that. So you'll watch those, and then there'll be some, problems here for you to try on your own, some additional lectures. And then after you watch all the lectures, every single week, there's going to be what I call a post-class assignment. And so your first one's already posted. Generally, the post-class assignments will be a short online quiz, in which case you'll get 2 attempts on them. So what'll happen is after your first attempt, when you take it, you'll get to see the answers you got right, but not the ones you got wrong. So, by process of elimination, you can see which ones you missed. And then you can go back a second time and try to improve on that score. Right? So every week you'll have to do. So that's the online component. Does anybody have any questions about the online component? No questions? Everybody's good? Kind of makes sense? And you can unmute yourself if you want to ask a question if you prefer that way. Okay. Going back to our syllabus. I'm going to talk more about the course content and outline when I go through our lecture today. But I also have posted here our course schedule that we're going to follow, and we're going to stick to this no matter what. So you can see, like today, what the topic we're going to learn is course introduction and the basic concepts of statistics, and you can see the remaining schedule there. You'll also see that I have 2 dates scheduled for exams. I'll talk about that in a second. And then we're very lucky we get election day off this year, so everyone should go out and vote. And then I'm also away the Tuesday before Thanksgiving, and on those days we won't have any class or any requirement, post-class requirement. All right, so what you're all probably very interested in right now is your grading structure, how your grade will be determined in this course. All right, so your grade is made up of 2 components. Right? The first one is called weekly assignments, okay, those post-class assignments. So there's going to be 12 post-class assignments given throughout the semester, all right? Basically, every week that we have a topic covered except an exam. There'll be a post-class assignment. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 post-class assignments. All right. Each of these assignments is worth 25 points, okay, for a total of 300 points. These homework assignments and their details, due dates will be posted in Blackboard shell. There's a post-class assignment for most weeks, including our first week of class. So you actually have a homework assignment. I know, don't hate me, the first week of class. All right. Post-class assignments will open in Blackboard every Monday night and be due the following Monday. Okay, so for example, your second post-class assignment will open up on Monday the 7th and be due Monday the 14th. So like this post-class assignment, loading up, this one is going to be due Monday the 7th. So you have to have your first weekly post-class assignment due on Monday the 7th. All right. You have an entire week to complete these assignments. All right. Because of that, no late assignments will be accepted for any reason. I stress this, okay? If you wait until Monday night to complete your assignment and something comes up, even if it's your internet going out, okay, that was a risk you took, right? And any missed assignment, you'll receive a score of 0. I try really hard to make the lectures, the post-class lectures that you would watch, all between 5 and 15 minutes. There's a few that go to 20, 25 minutes, but not too many. So all the videos that you would watch, any additional reading and the post-class assignment, not to take you more than 2-3 hours a week in addition to coming to class here. So it's really just trying to keep the same pace as a normal class or in-person class. Okay. In addition to those post-class assignments, there's going to be a midterm and a final exam, okay, in class. Each of these is worth 100 points. So the exams are going to cover the following materials, and you can see basically up here what they're going to cover. The midterm exam is going to cover our first 6 weeks of class, and our final exam is going to cover the next 6 weeks of lecture. Okay, the final exam is not cumulative, but you can do really well on the final exam without having mastered all the concepts of the first half of the course. Okay, for the final and midterm, all right, you are required to attend class via Zooms on those dates, and you have to just have your web camera turned on. Basically, it's just to try to prevent cheating. Your exams are still open notes. You can use your calculator, things like that. But it's just designed so that I know no one else is there working with you, okay? All right. Unfortunately, if you're uncomfortable with this, just register for a different section. It's the first day. It's not a big deal. And you know these dates way, way ahead of time. So if you miss it, you're going to get a 0. So no makeup exams will be given. Extenuating circumstances will be considered, but please plan accordingly for that. Okay. So numerical grades will be calculated by dividing the total points earned on exams and homeworks by the total points possible. So you can see your exams, your 2 exams make up 40% of your grade. They're each worth 20%. Your assignments total 60% of your grades. So there's 500 total points. So basically what I'll do to determine your grade, if you have 450 total points in the class, I'll divide that by 500. Your grade will be a 90, and I'll go down here, and you'll get an A in the class. Okay. This is my attendance policy on top of that. Attendance is an important part of the learning process. You should attend the full class, these remote classes, every day. There's a direct correlation between attendance and your grade. Without regular attendance, it's difficult to succeed. You're expected to attend class in a regular and punctual manner. If you miss class, the responsibility to watch the lectures that I record, and I'll just post those lectures to Blackboard shortly after class. I know that was really quickly the course structure, but does anybody have any questions about any of that before I go on? You can turn your mic on if you want to ask questions. All right, I promise you this. So I've been teaching this course, statistics, for God, over a decade. And if you, in this hybrid course I've been teaching for a number of years now too, if you keep up on the weekly assignments and don't slack off on them, watch the videos, attend my lectures, or if you miss a lecture, watch the 2-hour, the YouTube video that I post. I'll answer that question in 1 second that was just posted there. it's really hard not to succeed in this class. It's really hard. Most of the time, students who don't get A's or B's in this course are students who fall behind and just stop completing the post-class assignments. To answer the question in the chat, the assignments are not timed. Not timed. So you can open them and complete them at your leisure. To put your mind a little bit at ease about the midterm and final, I'm still working out how we're going to take the exam in Blackboard, but generally what I do for like the midterm and the final is there'll be like 10 questions on it, and I'll grade your best like 6 or 7 of those questions. So if there's some topics that you really struggle with, you know, when you come to the midterm and final, you can skip that question. And I'll also post practice midterms for you as well before that. Yes, you can use, excuse me, you can use notes if you want on there. For your assignments in class, you do have 2 attempts on them. I take your highest score. So if you take it once the first time and then you take it again and actually get a lower score, I'll still take your higher score. Generally, that doesn't happen though. Generally, what happens is students take it once and then they see where they made a mistake and they go back and they fix that. Any other questions? No, you guys will do great. I promise you. I know it's a crazy year. But well, it's a fun course, and I know teaching remote and learning via Zoom is going to be different for everybody, but you know, we'll get through it. All right, I'm going to get started with our actual lecture now. Before I do, does anybody have any final questions about that? Anything before I get going? Okay. All right, so I'm going to turn off my video just so we can focus on the lecture here. And I have the chat box opened up, so if you have any questions, you can post in the chat and I'll see them. Otherwise, you can turn your mic off and ask me a question. All right, so here we go. Welcome to statistics, everybody. All right, so what exactly is this course? What is statistics? All right, I'm going to give you the definition from our textbook. Okay, statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. So really, what statistics is about? Oh, sorry about that. What statistics is about? It's all about data. Okay, what can data tell us? Or what can we conclude from data? And if you think about it, we live in a world where there's a lot of data to consume. You know, you can see along the side of the PowerPoint here different graphs, and we're going to study all this type of stuff in this course. All right, so you know, there's a lot of different math courses you could take throughout this throughout your academic career, but like, why would you study statistics? Why do I love teaching statistics, and why I think it's such a valuable course? First off, data is everywhere. You should be an informed consumer of numerical information. You can't go through your day without seeing data. Oh, sorry. Getting used to this pen. So you see data everywhere. All right, and knowing how to work with data and consume it and make the correct conclusions from it are incredibly important. Statistical decisions matter. Okay, statistical techniques are used to make decisions that affect our daily lives. They affect our personal welfare. Here's a perfect example. With everything that's going on in the real world right now with COVID, has anybody been paying attention to the clinical trials that are going on for the vaccine for COVID? Has anyone seen anything in the news about that? hopefully we get a vaccine sooner rather than later, right? So these clinical trials use statistical techniques to determine the effectiveness of these vaccines. Okay, so once uh, doctors, PhDs, and MDs develop what they think is an effective vaccine, they turn it over statisticians to run it through clinical trials to see if that works. And some of the techniques that they talk about in clinical trials, well, I'll talk about in this course. So that's incredibly important right there. And I think I said this before, no matter what field of study you go into, what career you take, you'll make use of statistics. So I didn't always used to be a teacher, so I spent time as a mathematician for Lockheed Martin, and then I worked for New York State government as a policy analyst. And I'll tell you, every day of my job, I use statistics. Especially as a mathematician, obviously, but even in state government. And you wouldn't realize how important these skills are and how few people actually have them. So if you have these skills and bring them to the workplace, you'll be one up on all your colleagues. Okay, so this course, what I do is I divide this course into 5 sections of study, or 5 topics. Each are incredibly important. So what I want to do is just real briefly, this is also covered a little bit in the syllabus as well if you read this, but I want to go through it in a little bit more detail. So the 5 main sections of this course, the first one is an introduction, sampling, data types, graphical and numerical summary of data. This right here will take us about 2 weeks. This is the most number crunching part of the class. It's also, I'll be honest with you all, it's also kind of the most dry part of the class. We'll talk about things like bar charts, pie charts, mean, median. A lot of you know those things already. And there's not much like statistical theory behind it. Then we'll move into a section about correlation and regression. We'll go through this pretty quickly too. We'll do this in about a week and a half. Then we'll move into section 3 about probability and discrete random variables. This section here will also be about 1.5 weeks. We'll go through it pretty quickly. You'll learn a lot about probability and discrete random variables on your own. Section 4. Section 4 is kind of like the meat of the class. Okay, this is a section about continuous random variables, normal distribution, and sampling distribution. This has 2 different subsections here. We'll learn about something called the normal distribution. And this first subsection right here, this is where our midterm goes up to. So our midterm covers section 1, section 2, section 3, and the first half of section 4. A lot of this is because these first few sections are really just like, here's a formula, apply the formula. And the second part of the class becomes a little bit more theory-based. So the second part of this class here is about what we call sampling distributions. And we're going to spend about 5 weeks in all of this, a lot of time. Then our final section will be about what we call statistical inference. And there's 2 main topics here, confidence intervals and hypothesis testing. So I'll put CI and HT for hypothesis testing. These are the more advanced statistical theory topics of the course, and that'll take us the last 3 or 4 weeks of the class. And then your final exam will cover sampling distributions, confidence intervals, and hypothesis testing. All right, so let me break down these sections in a little bit more detail. Okay, so section 1, right? We're going to learn the process of statistics. Okay, we'll learn how to classify different data types. We'll learn that today. And then on your own, actually, this week, you're going to learn about graphical methods for summarizing data and numerical methods for summarizing data. So like the graphical stuff we'll learn about, or it's going to be like charts. The numerical stuff is going to be things like the mean, the median, and the mode. And who has heard of those things, the three M's, the mean, median, and mode before? Yeah, okay. When you think about the mean, right? That's like an average of some type. In the chat box, does anybody know what the median refers to for a data set? Median. Yep, middle value. Exactly. Exactly. How about the mode? What does that refer to? Yep, the one that occurs the most. Absolutely. Absolutely. So those are like easy ones. But then we'll learn about, stuff that you might not have heard of before. Okay. We'll learn about things like the range. We'll spend a lot of time talking about something called the standard deviation. Has anybody heard of the standard deviation before? But like, what exactly does it mean? If you've heard of it, if you haven't, that's okay. But like, I have this kind of concept of standard deviation. What exactly does it tell us about a data set? Then we'll learn about crazy stuff, something like what we call the interquartile range, the IQR. We'll learn about z-scores, all these fun numbers. I will be honest ahead of time. This part tends to be the most dry part of the course. A lot of it's just like, here's a data set, summarize it visually, summarize it numerically. But after you get through this section, the course gets a lot more interesting. All right, this section is what we refer to as descriptive statistics. Okay, this consists of methods for organizing and summarizing data. All right, so this includes the constructions of graphs, charts, and tables, and calculation of various descriptive measures, such as averages, measures of variations, and percentiles. So basically what this does is it takes data here, and it turns raw data into information. All right, it turns raw data into consumable information. Like if I have a data set of 100 values, basically this section just turns it, what's some information about this data set here? All right, the second section of class, one of the sections that I think is the most interesting. This is a section about two main topics, correlation and linear regression, okay? So in this section, we'll learn how two variables are related. Okay, I always like this example here. A few years ago, I had a big milestone in my life. I purchased my first home. If you guys want to throw some congrats in the chat box, that would be great. No, it was too late, too delayed. Oh, I don't know if I told this before, but you'll notice I tell a lot of bad jokes throughout the semester. Okay, I would appreciate it if mostly in class, I ask my students to laugh. There are a lot of dad jokes. Yes, I ask my students to laugh, but if you could throw me a pity LOL in the chat box, I would appreciate it. But so let me ask you this question. I paid whatever I paid for my house. So I actually live in New Jersey, so my house was very expensive for the square footage. But so there was the price I paid, and then my house has some square footage. Do you think the price I paid is related to the square footage of the house? Meaning, yeah, so how, yeah, sort of, yes, I agree, right? To a certain degree it is, yeah. So what type of relationship is that? Meaning, would you guys say that the larger a home is, the larger the square footage, the more a house sells for? Yeah, yeah. I mean, there are so many other variables that affect a house, right? Like number of bathrooms, location, things like that. But to a certain degree, yes, the price is determined by the square footage. So what we're going to do is we're going to learn two topics in this section. Correlation, this first one here. What correlation does, sorry for the correlation, measures the strength of the relationship. Okay, like how strong is the relationship between price and square footage, you know? Um, or, you know, you could even do it with like acres of land. You know, how strong is that relationship between the price and the acreage? Okay, then the final topic we'll learn about is linear regression, and this what this does is it models the relationship. And this section here, um, this is what we're going to actually do during our second week of the class. This section requires our use of our graphing calculators very, very heavily. So make sure you have, you know, hopefully, you know, you have your graphing calculator. Make sure you get it shipped by then because you're going to need your graphing calculator quite a bit for this section. All right, then our third section. Okay, this is going to be where we study the basics of probability. We'll start with very, very simple stuff in this class. Coin flips and die rolls we'll start with. You know, very, very simple. Actually, the first problem we'll do in this class, I always like to ask this to see if anybody could guess it. Suppose you take a fair coin, okay? Fair coin, what that means is it has an equal probability of landing heads or tails. If you flip it 3 times in a row, okay, you take that fair coin and you flip it 3 times in a row, what's the probability that you get heads 3 times in a row? Does anybody have a guess what that might be? That's actually the first problem we'll do. It's not 0.25. Anybody else? I see 1/8. Does anybody else have a guess? No other guesses? Everyone else is like, oh, 1/8 sounds good. Yeah, actually the answer is 1/8. Yeah. And I'm going to show you how to do that. So we'll start with very, very simple ones. Okay. Like, so the probability you flip a coin 3 times in a row, you get heads 3 times in a row. It's 1 out of 8 times that'll happen. So I'll show you how to do that. And then we'll work crazy, crazy harder problems. I've really tried to pick some very interesting statistical problems here, probability questions. One of the last questions we'll do is the probability that you win the Powerball lottery with a single ticket. All right, it's actually kind of interesting how you do that problem. You know, we'll work everything in between on that one. I'll give you a spoiler for the probability that you win Powerball. It's very small. Next thing we'll learn about is a random variable in statistics. So in mathematics, what letter do you generally let represent a variable? Yeah. In statistics, this concept of a random variable is going to be X, but it's going to mean something very, very different than what it does in algebra. To a certain degree in algebra, it represents some unknown value. It's kind of the same here, but we're going to tie our random variable, excuse me, to what we call a probability distribution. And it's going to be, it'll be really interesting. So there's 2 types of random variables in this class. There's what we call continuous, and there's called discrete. And I'll talk about those in this lecture later on. But in this section, we study what's called discrete random variables. They're actually pretty straightforward. We won't spend much time on it. We'll talk about things called expected values, and we'll learn about probability distributions. One of the first main ones we'll learn about is this thing here called the binomial probability distribution. And this is the crazy formula for it right here. And it looks rather complicated, this formula, but I'm actually going to show you how to use your graphing calculator for something like this. So while it might seem a little difficult, it's actually pretty straightforward. All right, section 4 of the course. All right, this is where we continue talking about random variables. This section will be our introduction to what we call Continuous random variables? We're going to learn about some new probability distributions. We'll learn about something called the uniform probability distribution down here. Then we're going to spend a lot of time talking about this thing called the normal distribution. And the normal distribution looks like this. Has anybody ever heard of this referred to as the bell curve? Anyone heard that before? Yeah, this distribution, incredibly important in statistics and has a ton of applications that we're going to learn about. I'm not going to give too much away here, but it's a distribution that's centered at the mean. And there's some values above the mean, but the further you get away from the mean, it's less. There's some values below the mean, and the further you get away from the mean, there's less of them here. This right up to this point here is where the midterm is that I talked about. Then once we come back from the midterm, we'll learn about something called sampling distributions. And sampling distributions are, sorry about the poor penmanship there, is your introduction to advanced statistical study, right? And this section will also learn about the most important theorem in the class called the CLT, right? So it stands for the central limit theorem. This is something that the central limit theorem is something that you'll use, especially if you go on to graduate study. But the whole concept behind a sampling distribution is this. Suppose you, gosh, there's so many classes meeting via Zoom right now, but if we take the average height of our class, okay, and we compare it to an average height of a different class we'll call C2, okay? Well, do you guys think the average height in our class will be the same as the average height in another statistics class? Yeah, probably not. Almost actually assuredly it won't be the same. So you know, averages across two different classrooms will be different. But then what happens if you do this for, say, 100 different classes, okay? And then you look at all the different averages, okay? You're going to notice something incredibly interesting and important for advanced statistical study. So we'll pick up with sampling distributions after our midterm. All right, section number 5. Finally, this is our final section. All right, we'll learn how to form conclusions from data. This is what's called statistical inference. All right, we'll learn about a topic called confidence intervals, and then we'll learn about a topic called hypothesis testing. Confidence intervals. You've actually all seen a confidence interval before and maybe not realized it. Has anybody paid attention to, I never want to talk politics in this course, ever, but there is some interesting applications of politics and statistics. What I mean by that is statistical polling. Has anybody, seen a poll in the news where it says like, X percentage of people plan to vote for the president, or something like, 40% support the president? Sure, you've all seen that. But if you look at a poll like this, you'll notice something down in the bottom of the corner. Generally, a poll is something, say, the margin of error. And if you paid attention to the news recently, like before I had a kid, my wife and I we were kind of news junkies. We always put on like CNN or something every night, and we've noticed more and more that they've been saying things like, "Oh, the polls are within the margin of error of each other." Thank you for the laugh there, by the way. The margin of error is actually constructed from a confidence interval, and I'm going to show you where those come from. Those numbers aren't just made up. Then our final topic will be hypothesis testing. What hypothesis testing is how you test the validity of a claim. All right. And a specific high testability of a claim in regard to a parameter, and I'll explain what a parameter is later. Right, like let me give you an example of a hypothesis test we'll actually do. Does anybody have a guess what they say the average amount of TV adults watch per week per hour is? So on average, how much TV do? The answer is too many. Yes. 15? Yeah. You know, we actually all watch a little bit more TV than we realize. Um, you know, like myself, for example, I'm a big baseball fan, so a lot of times I'll throw a baseball game on in the background and be kind of watching it, but that'll count. Um, you know, I'm a big Marvel, Star Wars guy, so you know, I like to watch those movies, you know, once a week if I can put it on in the background. Um, but the answer is like 30 actually. So on average, they claim that adults watch 30 hours of TV per week on average, which is a lot. It's like a full-time job. But my question is this, okay, I'm going to make a claim. I think WCC students watch less on average. Okay, so I think WCC students watch less television, less than 30 hours of TV per week. Do you think my claim is true or false when I say that? So here's the thing. Maybe, maybe it is true. Maybe it's not. So what I want to show you is a way with hypothesis testing to make a claim like that. So I just made a claim. WCC students watch less television on average. So I want to test the validity of that claim. And that's what hypothesis testing is. It's going to be a procedure to test to see if my claim is correct. All right. So that's kind of the overview of the 5 sections. And I know I've been going on for, oh, let me just hit this. This section 5 is what we refer to as inferential statistics. So it's the method of drawing and measuring reliability of conclusions about a population based on information obtained from a sample from the population. So what inferential statistics does? So before I said descriptive statistics turn data into information, what inferential statistic does, it takes data and it turns it into knowledge or some type of conclusion from the data, right? Or what can we learn from the data? Right? Here's a perfect example of this inferential statistics. So statisticians analyze the information obtained from a sample of the voting population to make inferences or draw conclusions about the preferences of an entire voting population. You know, when I talked about those political polls, so when a poll says something like 40% of Americans support the president, do you think they talked to every single adult American in the United States to be able to get that 40%? Yeah, absolutely not. Okay, they didn't call me, they probably didn't call you. So it turns out what they do is they take a sample, small number of people, generally around 1,500 people if they can, believe it or not. And what they use is they use that sample to say something about the entire population of all Americans in the United States. And that's actually a perfectly valid statistical procedure. And I'm going to show you, talk to you about the theory behind that in the coming weeks. Okay, so actually what I want to do here, so I've been going on for quite a bit, about 55 minutes straight. So I always like to take a break. I always like to take a break at this point here, just for, let's say it's 9:55. Let's take a, gosh, let's take a 8-minute break. Let's start back at 10:03. Does that sound okay with everybody? Get up, just stretch your legs. All right, let's So let's say we'll start back at 10:02-ish. Okay. All right, so I'm going to go refill my coffee. I'll leave the timer up there so that we can see. But before I do that, before I go refill my coffee, does anybody have any questions about any of the first half of the class? Okay, I'll be back in a little bit. I'm going to mute my mic and I'll see you guys in about 5, 10. All right, just a quick mic check again. Can everybody hear me again? Okay. I hope the break was helpful. Um, we'll take it every class. I just find that after about an hour, 55 minutes or so of listening to the professor, everyone needs to get up and stretch their legs, myself included. Okay. Let's finish up the lecture. Okay, so what we've spent the first half of class talking about, was what is statistics, how's the courses divided up. Now let's actually get into statistics and data. Okay, so what I want to talk to you about now is what we call the process of statistics. So statistics is a 5-step process, right? So the first step of the class, or the first step in the process of statistics, is to ask a research question. Okay, something you're interested in. This right here is what we call a hypothesis. Okay, or a claim. Like, for example, the claim I had right before the break was that WCC students watch less television on average than the general adult population. So for this course here, whenever we are going to work with data or statistics, I will come with the research question. So you don't have to worry about this. So Matt will come with this. As you go on in your academic career, especially if you go to graduate school, you'll develop your own research questions. The second step is you're going to design a study and collect the data. This right here, Matt will also provide data for us. So this class isn't really about the first 2 steps in the process. So you're going to design a research question, and then to test the validity of that research question, you're going to design a study and collect the data. After you do that, the third step, here you're going to explore the data. This right here is section number 1 of the class. All right, so this is that descriptive statistics. All right, that's what we're going to spend the first 2 weeks learning about, like taking raw data and turning that raw data into information. So data into information. The fourth step in the process is drawing inferences and formulate conclusions. This right here is section number 5 of the course. Okay, which is funny. It's interesting because we just go from section 1 right to section 5 in the process of statistics. So a lot of it is like, well, where's sections 2, 3, and 4 of our class in this process of statistics? Well, actually, to go from 1 to 5, each section builds on each other. So you're going to need to know all the relevant theory and information in sections 2, 3, and 4 to be able to get to section 5. So this is our course. So like an entry-level stats course is steps number 3 and number 4 in this course. That's what we're going to learn about. Basically how you take a data set, how you explore the data, turn that data into information, and then here, how you take that data and turn it into knowledge. Not too often, but today what we'll do, the final step in the statistical process, is a reflection, kind of like a look back, okay? And basically what this does is, can the study be improved? Or what are issues with it? Okay, so ask a research question, design a study and collect data, explore the data, draw conclusions from that, and then a reflection, kind of a look back. All right, so what I want to do now is I want to do an example about the statistical process, I actually want to walk you through a real statistical study and show you all the 5 steps in action. So actually what I want to do here, can everybody see the poll that I just posted up there? Can everybody see it? So this poll is anonymous, okay? But I want to do a kind of like a little bit of a macabre example, okay, here. And if you're, I don't know if everyone's still paying attention, but I hope that you are. But I would like everyone to participate in this poll. So I'm going to leave it open for about 1.5 minutes. And here's the question I want to ask everyone. Is organ donation a good thing? Okay, does everyone think being an organ donor is a good thing? All right, and you don't have to say yes. You know, I'm just curious what everybody in the class thinks. You know, is being an organ donor a good thing? Almost everybody has it posted. I'm just curious. I've never done a Zoom poll. Can you guys see the results yet or no? Okay. All right. I'm going to close the poll in a second and I'll show you the results. Okay. So this is just the question. Is being an organ donor a good thing? So here's the results. You guys see that? Let me see. Can you guys see that results right there, what the class thought? That's crazy. So the vast majority of people in this class said, yeah, being an organ donor is a good thing. So something like 91%. Okay. But now here's I have a follow-up question, okay, for this. And please don't lie about this because this is anonymous, so I don't see the results, okay? So the vast majority of us in this class are saying being an organ donor is a good thing, okay? Now let me ask you a follow-up. Here's the follow-up question. Are you actually an organ donor? Yes or no? I'll give you another couple of minutes to answer this question. While I'm sipping my coffee. Yes, I do mean registered to be an organ donor. Yep. So we saw the percentage of people that said, you know, I think being an organ donor is a good thing. Now I'm asking what percentage of you are actually registered to be an organ donor. Remember, 91% of you said, yeah, being an organ donor is a great thing. I'll give you another 5 seconds. If you haven't answered, then I'll answer, and I'll show it. Look at this. That's okay. Being off by 1 is okay. Everybody see the results here? That's crazy, right? Look at this. 91% of you said being an organ donor is a good thing, but then only 72% of you actually went out and became an organ donor. Okay. Yeah. Does anybody know how you become an organ donor? Just out of curiosity. You become an organ donor, yeah, right there. Thank you, Brittany. Yep, to the DMV. Can you guys see my video here? I'm going to cover up the information here. I don't know if you can see this. Probably not, but here's my driver's license. Trying to cover up the information here. But down in the bottom corner, I don't know if you can see it. Mine says I'm an organ donor, okay, in New Jersey. So when I grew up in New York, actually. So you guys are right. When you become an organ donor by the process of applying for a driver's license. So in New York, okay, the way New York does it is very different from how people in New Jersey become organ donors. So the way it works in New York is you show up at the DMV and you have this big, long application process. And one of the questions built into the application process is, would you like to be an organ donor? Okay. So do you think every person who sees that question on their driver's license application answers it? Okay, what do a lot of people do when they see that on their driver's license? Let me ask you this. Can you leave it blank? That's exactly right. Yeah. You can just ignore it. You can just leave it blank. Okay, you can skip the question, doesn't matter. If you skip the question in New York State, um, does New York State make you a organ donor, or does it not make you an organ donor? It does not. That's right. It is default to be no. So New York State makes a default choice for you. Listen to what I'm saying. New York State says, unless you want to be, you are not an organ donor. So what I'm saying here is they say you can opt in being an organ donor. Okay. New Jersey was very different. So I met a Jersey girl, so obviously I live in New Jersey now. And so when I was switching over my driver's license, they actually don't call it the DMV, they call it the MVC. It's the Motor Vehicle Commission in New Jersey. They do everything weird in New Jersey. But so when I was at the MVC, I'm talking to the individual who's doing my driver's license. She says, "Okay, sir, a final step in your driver's license application was you have to answer this question." And right on the screen, it popped up and it said, "Do you want to be an organ donor, yes or no?" And I had to make a choice. Okay, I could not leave it blank. I had to choose. Okay. So the two states do it very differently. All right, so let me throw some information at you, and we'll talk about a study here, okay? So even though organ donation saved lives, okay, recruiting organ donors is difficult, okay? Like we just saw here, 91% of you said being an organ donor is a good thing, but only something like 20-something% of you were actually organ donors. Okay, surveys show that about 95% of Americans approve of organ donations in principle. Many states offer a simple organ donation process when you apply for a driver's license. Okay, turns out that across the country, okay, only about 54% of licensed drivers in the United States are registered to be organ donors. I think in New York State, let me go back. It's about 30% of people who are registered organ donors, okay, which is kind of almost what we saw here. You guys think New Jersey is better than you guys in terms of being organ donors, the way they phrased the question? My great, I like that answer. Yeah, New Jersey, but it's not actually that much different, believe it or not. It's roughly about 40%. I'm just curious, does anybody have a guess who the highest state is in terms of percentage of its populace who becomes organ donors? So the best state for this? It's not California. Nope. You would think it's not Oregon, not Maine. Nope, not Florida. Ha, no. Nope, nope. Not Maine. Nope. Texas, not. I was born in Texas, not Texas. Nope, it's not Hawaii. Nope, that city. Nope, Utah. Nope. All right, I'm gonna stop. No one. I've actually never had anybody guess this in all the years I've been doing this. For some reason, it's Montana. There's something like 95% of people chose to be organ donors in Montana. I don't know why. Okay, I can't answer that, but it's Montana. That's a good answer. There's about 500,000 people, I think, in. Are you in Montana? Really? That's funny. Yeah, I think there's about 500,000 people in Montana. I'm not sure. Yeah, it is a small population, but remember, we're still talking about the percentage of the population. So population size doesn't necessarily matter here. But it's just interesting. I can't tell you why. I don't know the driver's license application and process in Montana, so I can't even tell you. Okay. But here's the thing, going back to this, okay? New York, New Jersey, okay, they're actually on the lower end here. Okay, so 95% of people think it's a good thing, but only 54% of people in the United States are, okay? So some people, one of the reasons it's really hard to recruit organ donors is you have to make some people prefer not to make an active decision, okay? right? Because the topic can be unpleasant to think about. So, for example, if I wanted to become an organ donor, what did I have to think about? Yeah, I had to think about my death. I had to say, when I die, this is what I want to happen. Okay, so it's an unpleasant topic to think about. That's why, like, a lot of people in New York just skip the process. All right. Anyway, so here's a hypothesis. Okay, this is step one in this procedure going back here. Okay, I want to ask a research question. Yeah, it is a little too real for people. Okay, so here's my hypothesis. Okay, this is step one here. And I'm sorry it's red here and you can barely see it. But, my hypothesis here is perhaps phrasing the question differently or how it's presented different to people will affect people's willingness to be a donor. Okay, so we want to use statistics to figure this out. Okay, so this simple exercise will be our first look at how we solve problems in this course, all right, using the process of statistics. Okay, so this question, okay, this organ donation question here follows an actual study. So there's the link to it. It's a study done by Columbia University. And so let me tell you about this study, okay? So these professors at Columbia University said, all right, I want to see if we can get people to choose to be organ donors at a higher percentage, okay? Like through the driver's license application. So they put flyers all around campus on Columbia University, and they asked people to show up to be part of the study. Okay, and they did not tell the people what the study was about. Okay, so people just showed up in the study, and what they had them do was they had them pretend to apply for a driver's license. Okay, they just had to say, everybody, you're going to pretend to apply for a driver's license. And it was a complete application. Okay, it's an eye color, where do you live, your height, all this stuff. It was a big, detailed questionnaire. And then embedded within the question, or embedded within the driver's license application, participants got assigned to 3 different groups of people asked about applying to be an organ donor. Okay, so they took all the students and randomly put them into 3 groups. Okay. So the 3 groups that you got put into are the following. Some participants were forced to make a choice of becoming an organ donor or not without giving a default choice. Okay, this was called the neutral group. Okay, this is how it's done in New Jersey. Okay, so they say, look, you have to answer this question. Right? You have to choose to be an organ donor or not. Other participants were told on the driver's license application that the default option was not to be a donor. Right? But they could choose to be a donor if they wanted to. So this is called the opt-in group. And this is how New York does it. Okay, this is how everybody, except for the person living in Montana, that's how everybody in New York applied for it. All right, the remaining participants were told that the default option, it said the following: you are going to be an organ donor, okay, but you can choose not to be a donor. Okay, so you can opt out. Okay, and I actually don't know any state that does this. Okay, off the top of my head. Okay, but so the default option here was being changed to the participants in the study. Right, so here's my question for you all. Do you think that some groups or some default options will likely influence people's choice to become organ donors or not? So how it's presented, do you think it will influence? Okay, got one yes, yes. Maybe, maybe, right? I don't know. I do know, I've taught this lecture once, but you gotta know. Okay, just out of curiosity, let's suppose that the default option might impact it. Which one do you think would be the best? The way New Jersey does it, the way New York does it, or telling people that you are a donor but you can opt out? So out of the options 1, 2, or 3, which one do you think would be the most likely to get organ donors? I wish it was New Jersey. Okay, so it seems like a lot of people think it's 3. So the reason, here's the theory behind it, right? You don't want to make an active decision. It seems like they're making a decision for you. Great. So maybe that'll be the best. Okay, so here's the 5-step process of statistics that we were talking about. Okay, step one was your hypothesis right here. Okay, does the default option presented on the driver's license application influence the likelihood of someone becoming an organ donor? So we want to answer this question, and there's two answers to this. Yes, it does. The default option does, or no, it does not. Okay, there's two options there. Okay. Step two was you have to design an experiment and collect data. Okay, so they recruited the various participants and asked them to apply for a driver's license. They randomly assigned them to 3 groups. Okay, all right. Step three, you have to explore the data. This is descriptive statistics, or section 1 of our course. Okay, so let me show you what they did here. Okay, so they took the data, and these are the 3 groups. Okay, this is the opt-in people. Okay, this is the New York people. This is opt-out. Okay, this, I don't know what state it was that does this. And the neutral group, where you had to make an active decision, that's the New Jersey way. Okay, what this chart is called here, this is called a cumulative frequency bar chart. Okay, and what you're seeing here is roughly this percentage of people chose not to be donors. So it looks roughly like 60% not, 40% chose to be donors. That's like what's happening in New York. And then if you look at the next two, they're roughly the same. They're off a little bit. But the 2 other options look like 20% of people chose not to be donors, and 80% of people chose to be donors, and 20% of people here roughly chose not to be donors, and 80% of people here chose to be donors. Does it look like there's a discrepancy between the 3 groups? Meaning, do 2 of the groups a lot better than another one? Absolutely. Absolutely. I'm not saying that my new state of New Jersey is better than your guys' state of New York, but it just seems like it is here, you know? That was a joke, by the way. But it does look like right here, okay, these 2 ways seem to have a greater impact on people becoming organ donors. Either one, you make them make a choice where you say you have to be an organ donor, or the default is an organ donor. So which state does it look like has the worst way of recruiting organ donors, just out of curiosity? Yeah, for whatever reason, New York State, the way they've chosen to recruit organ donors seems to be the worst way in actually recruiting donors, okay? Okay, so now our step 4 here, okay, this is our conclusion step. This is section number 5 of our course. Okay, what do you guys think? Okay, is there evidence to support something? Meaning, when we go back to answer our question here, right? Does it look like the way it's presented influence people's likelihood to become organ donors? Absolutely. Yes. It absolutely seems this way. Okay. It absolutely seems like how it's presented to people will influence their likelihood to become an organ donor. Okay, great. So this study comes out of Columbia, and it's like, yes, we have this new way of finding organ donors, but like, there's some major issues actually with this study. So this is why sometimes in this class we're going to go back and look at step 5 and look at a reflection about this study. Okay, so there's actually 2 major issues with this study. And just for time restraints, I'm going to just talk about it. The first one is, and maybe you can talk about this in the chat, who were the people they interviewed or recruited for this study? Students from where? Oh, got people, yep. They only talked to Columbia students, okay? Not only that, they only talk to Columbia students who are willing to be part of a randomized study here, okay? So when you see these conclusions, you can really only extrapolate the results to talk about Columbia students who have a propensity to volunteer to be part of studies, okay? So our results only can be applied for Columbia students. All right, because we only sampled from Columbia students, we can only say something about all of Columbia students, okay? So that's a huge issue, okay? Like maybe there is something different about Columbia University students than the population as a whole, right? My beautiful wife went to Columbia. There's definitely something different about her than the population as a whole. Don't tell her I said that. And then the final thing is there's something called response bias, okay? When students get a study like this and they see this question, they are primed to give the response they think people want to hear, right? Because what they know is someone's going to see my driver's application and they're going to see my result and they're going to judge me. So they're going to give the result, they're going to tell people what they think they want to hear, okay? So right off the bat, you gotta see if that's an issue here. And it is, because if you look back here, now let me go back, sorry. You know, even in the New Jersey example, only roughly, in the real world, only 40% of people, when they had to make a choice, chose to be organ donors, but we're seeing in this study, it's 80%. So there's, people are giving the response they think they will. Okay, interesting a little bit. I hope that was an interesting example. I think it is. Okay. I want to quickly go through as much of the rest of this I can in our final 20 minutes together. Okay. Now what I want to start talking about is some key definitions for this course, all right? And I'm going to spend some time talking about these because they're incredibly important. All right, so in statistics, we're going to have two types of data sets or collect, right? We can have what's called a population data set, or we can have what's called a sample data set. So a population is a collection of all items of interest or under investigation. A population data set, the way I like to think about it, is it's a data set of complete information. Okay? You know all possible data values. Okay? Like, let me give you an example of a population. All right? We can have a list of all WCC students. Okay, like, do you think the college is able to produce a list of every single student who's enrolled at WCC and give me that list? Absolutely, they can, right? And now we want to put numbers to this. So we're going to let the capital letter N represent the population size, okay? And there's roughly 10,000 full-time students at WCC, okay? So a population, complete information. Whenever you see the capital letter N, this is really important. I know it seems silly to highlight, but it's really important. Whenever you see the capital letter N, okay, that's going to represent the population size. Next, we have what's called a sample. A sample is an observed subset of the population. So it's data taken from a population. And the way I like to think about it is it's incomplete info. Okay, it's just a small subset of the population, okay? Let me give you an example of a sample. A political poll participants, okay? You know, when a political poll comes out, they're not able to call every single person in the United States, so they take a a small sample, an observed subset. We let lowercase n. So whenever you see a lowercase n, okay, I know it seems silly, but there's a subtle difference. Capital N represents a population size. Lowercase n represents a sample size. And political polls roughly try to get 1,500 people. Okay. All right, so data can be thought of values measured on or categories recorded on individuals, entities of interest. And so now, once we have data, we have two very important definitions. A parameter is a specific characteristic of a population. Okay, so the way what I think about parameters are values calculated from a population are parameters. So generally, whenever you see parameters in this course, we're going to use Greek letters for them. Like we're going to use this Greek letter mu that looks like a U, or then we'll use this Greek letter sigma. Okay. This comes from whenever you calculate a value from a population, it's called a parameter. Statistics here, okay, that's what this course is called, statistic, is a specific characteristic of a sample. So this is values calculated from a sample. And we call these statistics. And what we're going to learn in this class is really how you use statistics, all right, to say something about an entire population. All right, let me give you a visual here showing you the difference between a parameter and a statistic. I know this seems like a silly example, but suppose you take all the letters of the alphabet. How many letters are there in the English alphabet? 26, yep. And I know this seems silly, but imagine all the letters are paid a salary based on how much they're used, okay? So like the letter A makes a lot of money, the letter Z doesn't make a lot of money, okay? If you were to calculate the average salary of all 26 letters, that would be a parameter, okay? If you were to take an observed subset or a sample of these 1, 2, 3, 4, 5, 6, 7, 8, 9 letters and calculate the average salary here, that would be what's called a sample. Okay, so parameters come from everybody in the population. Statistics come from just a sample. Okay, here's like another way you can see the relationship between a population and a sample. Okay, here's the entire population. Imagine these are all the individuals. Okay, if you want to take a sample of this, okay, this would be the observed subset. Values calculated from all these individuals would be parameters. Values calculated from just these four here would be called statistics. Okay. All right, let me give you a real world example of this, okay? So I've been talking about this a lot here. Political polling provides an example of inferential statistics. Interviewing everyone of voting age in the United States on their voting preference would be expensive and unrealistic, okay? There's just actually like literally no way you could talk to every single person in the United States. There's just not enough time in the day for people to do it. All right, so statisticians who want to gauge the sentiment of an entire population of US voters can afford to interview only a carefully chosen group of a few thousand people. This group is called a sample of the population, okay? We'll actually do a lot of survey questions or look at a lot of polls in this class in the coming 15 weeks together. I talk about my wife quite a bit, but my wife is actually a survey researcher, a pollster, so sometimes we'll actually look at her polls in this class. All right, so for example here, this is one of those polls, the Rutgers-Eagleton poll. What it says is 2/3 of New Jerseyans feel the state is moving at the right pace to reopen. Okay, this is for COVID, reopening the state. So what you can look at here, here's the sample if you were to read that study. Okay, the results are from a statewide poll of 1,502 adults, all right, conducted by live callers on landlines and cells. So this is our sample size here. All right, but the population that they're drawing this from, all All right, we're drawing a conclusion here for all people who live in New Jersey, and this represents the population size. So this is the statistic. 2/3 of people think the state is moving at the right pace. And what we're saying is we're using this to estimate for the population. All right, I'm sorry I'm going a little fast here. I just want to try to get as much as I can done in the next 13 minutes. Okay, talked a lot about data in this class. So there's different ways you can classify data, okay? So the first way you classify data is what's called qualitative or categorical values or quantitative values, okay? Qualitative data allows for classification of individuals based on some attribute or characteristic, okay? So think about qualitative data as categories we fit into, okay? Like, for example, individual sex, okay? You're either male or female, or a grade level. You know, are you a freshman? Are you a sophomore? Okay, those are qualitative, okay? Next, we have categorical variables. These provide numerical measures of individuals, okay? So quantitative, think of them as numerical measures. Good thing, things like how tall people are, height, or you can even count values that are counted like number of cups of coffee consumed per day. For example, I'm on my probably 4th cup of coffee. Right? Having a newborn at home keeps me up at night, so gotta consume the coffee. All right, so whenever you collect data, it's initially classified as either a qualitative or a quantitative variable. All right, so here's some examples of qualitative. Eye color, smoking status, attitude towards the death penalty. These are categories you fit people into. Quantitative, numerical measures, pulse, height, age, exam marks, size of a bicycle frame, time to complete a statistics test, number of cigarettes smoked per day. These are things that are numerical measures on people. All right, qualitative data is just qualitative data. But quantitative data can then be broken down. Okay, once you have quantitative data, you can classify it either as a discrete variable or a continuous variable. Okay, qualitative is just qualitative. Okay, if you read the textbook, there's actually, they break down qualitative by either what's called ordinal or nominal, but for our course purposes, we're just going to call qualitative data qualitative. But quantitative data can be discrete or continuous. Discrete variable or data is a quantitative variable that has a finite number of possible values or countable number of possible values. So think of discrete as counts, all right? Like the example was the number of cups of coffee consumed. Okay, that was an example of a discrete variable because it's a count. Continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. These tend to be measurements of some type. So measurements on individuals, okay? These are things like an individual's height. Okay, here's some examples of these discrete variables. The number of children in a family, like I have 1 child. Right? Here's a trick to help you figure out if it's discrete. Like if you know the next possible value, like it's countable. Like if I have another child, it would be my 2nd child. Like you know the next possible value, right? number of students passing the stats exam, number of crimes reported to the police, number of bicycles sold. They're all counts. Continuous, okay, height, time to run 500 meters, temperature outside. These are all measurements. Okay. Generally with these here, the way you can also tell is you don't know or can't report. Next possible value. Like for example, if I tell you outside right now, it's 70 degrees Fahrenheit, what's the next highest temperature? Is it 71? Is it 70.01 degrees? Is it 70.00002 degrees? You can't possibly know, okay? I'll let you do this on your own here to think about these as if they're discrete or continuous. Think about if they're measurements or counts. And then on your own, if you go back, I also have the solutions here for you. Okay? All right, different sampling methods. There's 4 types of different ways to collect data, main ways to collect data in this class. There's what's called simple random sampling, stratified, cluster, systematic sampling. Okay, I'm just going to go through these really quickly at lightning speed. All right, simple random sampling is a procedure in which each member of the population is chosen strictly by chance. Each member of the population is equally likely to be chosen. The result is called a random sample. This process of simple random sampling is the most important in our class. It's the procedure of sampling for which advanced theory is based on. The way you can think about simple random sampling is it's like drawing names from a hat. Everyone has the same chance of being picked. Stratified sampling is obtained by separating the population into non-overlapping groups. So here's the population of people. All right. Every dot represents a person. All right. So what you're going to do is you're going to separate the population into non-overlapping groups. Here's group 1. Here's group 2. Okay, separate them into non-overlapping groups. And then what you would do is you would take a random sample from each of these groups. So sample from here, sample from here, and then you would pull those groups together, and that would be your stratified sample. Cluster sampling is obtained by selecting individuals within a randomly selected collection or group of individuals. So cluster sampling is a little bit different. So this right here would represent all our population, all these individuals. So you'd separate the population into different groups, just like you did with stratified. And instead of taking a few people from each group, you would take all the people from this group and all the people from this group together, and that would be your cluster sample. Systematic sampling is obtained by selecting every kth individual or object from a population. So like a way you could think about systematic sampling is if you had your entire population all lined up. You would say, take every second person. So I would take this person, and this person to be in my sample. That would be systematic, where you do it in a systematic way. Here's just a visual for you on your own to review, to kind of just see this. These methods, I know I went through them really quick, are also covered in the textbook in detail. The final thing I want to talk about here is errors in sampling. So there's 2 types of errors. There's what we call non-sampling errors, and sampling errors. The whole idea of sampling is you want to use a sample to estimate the value or values for a population. All right, that's the whole point of these collecting samples. And now what I love about statistics is sometimes you're going to get it wrong. Okay, so sometimes when you collect a sample and you want to use that sample to say something about the entire population, sometimes statisticians just get it wrong. And the reason they get it wrong can be due to non-sampling errors, right? These result from the survey process and are due to non-responses of individuals selected in the survey, inaccurate responses, poorly worded questions, things like that. These you try to control for. All right, like for example, the census is going on right now. I don't know if anybody sees this in their neighborhood, but some people don't fill out their census, right? So non-responses of individuals. If you don't fill out your census, what does the government do? What do they try to do? They try to send a census taker to your door to ask you. You know, so I've been seeing a census. Yeah, exactly. I've been seeing a census taker going around in my neighborhood. Inaccurate responses. That's a tough one. You know, sometimes, for example, if I'm selected for a survey and they say, "Hey, Matt, how much money do you make per year?" And I say, "I make $1 million per year." That's not true. That's an inaccurate response. All right, so these are non-sampling errors. Sampling errors, these you can't always control for. Okay, these are errors that result from using sampling to estimate information regarding a population. These type of errors are because a sample gives incomplete information about the population. For example, suppose you, and I'm going to go over 2 minutes today. I'm sorry if you just bear with me. If you want to estimate the average income of people in the United States, and you call 30 people, and the first 29 people you have are normal jobs, you know, doctors, lawyers, nurses, teachers, firefighters. But then the 30th person you call is like Mark Zuckerberg, who owns Facebook, and he says, "I make $20 million a year." That average salary of those 30 people would not be indicative of the real population. Okay. So sorry about going over a little. I've actually got 1 minute left. So that was our first lecture. I hope everybody enjoyed it. What you have to do on your own this week, going back into the classroom, you should watch all the lectures that are posted below. Okay, and then once you reviewed the lectures and read the section in the textbook, you should take the week 1 assessment. Okay, I'm just going to load it up for you real quick. And you can see the type of questions that I ask. Some are multiple choice, some you have to figure out the answer, multiple choice, write in the answer, things like that, okay? You have 2 attempts at it, your highest one counts. And before I let you go, does anybody have any final questions for me? Okay, so when do we meet again? So I have 2 questions. First, when do we meet again? We meet again next Tuesday. I will send out an email with a meeting requirements and reminders, so we meet 1 week from today. There was a private question sent to me. It says, how long after this class is the video posted? I post the videos to YouTube, and I'll send you the link. So however long it takes for the video to render and then the video to post to YouTube, given the length of this video, I'd probably say about an hour. And then I will post it in the classroom. I'll show you where. What I'm going to do is I'm going to post it under the course meeting materials. What I'll do is I will, for this week only, I'll save my PowerPoint with all my writing in it for you. I'll post that here, and I'll also post a link to the video there. All right, I wish everybody the best of luck with the rest of their courses today, and I hope, remote teaching and learning goes okay for everybody. All right? I'm going to end the meeting, and then I'm going to go to my office hours if anybody has questions for me. Thanks, everybody. Great first class.